Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals, right? So here we have this problem involving Signum function, right? So here the integral of x e raised to Signum of x minus pi by 4 from 0 to pi by 2 is given as pi square over 32 1 over k plus 3k, and we have to find the value of k, right? So here this integral, it involves Signum function, right? So viewers, here we have to find the value of this constant k, and let us first take this integral, right? And let us call this integral as I. So I is from 0 to pi by 2, and we have x e raised to Signum of x minus pi by 4 dx, right? So here we'll try to find out the value of this integral using the concept of Signum function, right? And then we'll equate that value to this value, right? So now let us first look at this integrand. So our integrand is f of x, and we have x e raised to Signum of x minus pi by 4, right? And now here e is the exponential number, and let us concentrate on this Signum function, right? Now from the definition of Signum function, we know that Signum of say y is equal to plus 1 whenever y is greater than 0, and Signum of y is equal to 0 whenever y is equal to 0, and it is Signum of y is equal to minus 1 whenever y is less than 0, right? So now here we'll apply this definition to this function, right? So Signum of x minus pi by 4 is equal to here for y we can take x minus pi by 4, right? So Signum of x minus pi by 4 is equal to plus 1 whenever x minus pi by 4 is greater than 0, and Signum of x minus pi by 4 is equal to 0 whenever x minus pi by 4 is equal to 0, and Signum of x minus pi by 4 is equal to minus 1 whenever x minus pi by 4 is less than 0, right? Now here we have these two inequalities, and this is the equation. So here we have x greater than pi by 4, and here x is equal to pi by 4, and here x is less than pi by 4, right? So this is how we define our Signum function, and let us now concentrate on the lower limit and the upper limit, right? So here we have to integrate this function f of x from 0 to pi by 2, and we see that this is 0 and this is pi by 2, right? So this is the lower limit and this is the upper limit, and between 0 and pi by 2 we have the point pi by 4, right? So we have this point. So pi by 4 lies between 0 and pi by 2. So what we will do, we'll split this integral I as a sum of two integrals, right? I1 and I2. So I1 is from 0 to pi by 4, and I2 is from pi by 4 to pi by 2, right? Now here we also see that whenever we take any value of x between 0 and pi by 4, then x is less than pi by 4, and whenever we take any value between pi by 4 and pi by 2, x is always greater than pi by 4, right? So in this section we have x less than pi by 4, and in this section we have x greater than pi by 4, or in other words we can say that we have two intervals. The first one is from 0 to pi by 4, and the second one is from pi by 4 to pi by 2, right? So now our integral I can be written as a sum of two integrals I1 and I2. So I1 is from 0 to pi by 4, right? And our integrand is x e raised to signum of x minus pi by 4 dx, and I2 is from pi by 4 to pi by 2, right? And we have x e raised to signum of x minus pi by 4 dx. So now here signum of x minus pi by 4 will take the value minus 1, because x is less than pi by 4. It means we are in between 0 and pi by 4, so we have I is equal to 0 to pi by 4, and here we have x e raised to minus 1 dx, right? And in I2 we have from pi by 4 to pi by 2 we have x e raised to plus 1, right? Because signum of x minus pi by 4 will take the value positive 1 whenever x is greater than pi by 4, right? So we have now these two integrals, right? And what we will do, we can simplify. So e raised to minus 1 is a constant, so we can take it outside. So we have e raised to minus 1, 0 to pi by 4 x dx, and here we have pi by 4 to pi by 2, and we can take e outside. So here we can write, here we have x dx, and here we have e and x dx, right? So therefore I can be written as 1 over e raised to minus 1 is 1 over e, and the integral of x is x square over 2, and the limits are from 0 to pi by 4, and here we have e and x square over 2, the integral of x, and the limits are from pi by 4 to pi by 2, right? And we can further simplify it. We can take 2 outside, so we have 2e and x square 0 to pi by 4. Here we have e over 2 x square pi by 4 to pi by 2, right? So now we can write it as 1 over 2e. We can substitute the limits and we'll take the difference. So we have pi square over 16 minus 0, and here we have e over 2, and we have pi square over 4 minus pi square over 16, right? So now I is this is pi square over 32e, and here we have e over 2, and 4 and 16, the LCM is 16, so 4 4s are, so 4 pi square minus pi square, and this is pi square over 32e plus this is 3 pi square, so we have 3 pi square e over 32, right? So viewers, the value of this integral, that is this integral, is now I is equal to pi square over 32. We can take pi square over 32 common, and we have 1 over e plus 3e, right? And this is the value of this integral, and we have already given this value, right? So we are given pi square over 32, and here we have 1 over k plus 3k, right? And now if we compare both these sides, then we see that k is equal to e, right, where e is the exponential number, right. So this is how we find the value of k, which is equal to e, and this is how we solve this problem.